All right, I'm going to take a drink. Okay, carbohydrate for energy. So when you are resting, fat is your main energy source, and at low intensity exercise. Okay, but I'm going to take a little bit of a detour here. If you remember from 153, so those of you who were not in 153, here is something to think about. That even though at lower intensities or at rest, fat is the primary energy source, when we talk about intensity and we talk about total calories burned, the relationship we want to look at is more of within there, and you're looking at how many calories burned. Is it still then advantageous to do that long, slow exercise at that low intensity because fat is primarily burned, or because of the total number of calories that are burned at a higher intensity, will you end up still burning more fat at the higher intensity along with the carbs? Did that make any sense? You know, so you're looking at, in the low intensity, the higher percentage of your energy source is coming from fat, okay? But you're only going to burn maybe at, what, 150 calories there. That's just a number I'm throwing out there. But at the higher intensity, even though fat isn't the primary source that's used, so the percentage is less of fat than at the lower intensity, because you're burning a higher number of calories at the higher intensity, you still at the end are going to burn a higher number of calories from fat. Okay, so doing, and I know you guys have seen the high intensity interval training. If you've had me for stuff, you've heard me talk about it, because I truly believe if you're working with somebody who wants to lose weight, that's the route to go. Number one, it fits the time. Not everybody has the time or the desire to go out and run 10 miles, you know, but if you can, in a few high-intensity interval training sessions of 20 to 30 minutes, including warm-up and cool-down, that's probably the direction, you know, that they would want to go. So, so using a high-intensity interval source, so even though fat's the main energy source, you're not burning as many calories. Thoughts, question, comments there? Did I finally bring it around that it made sense? Sam?
Well, if you were to have a client who isn't really in the state to do high intensity exercises, would a good plan for them to be to cut out carbs in their diet? That way, fat is their main energy source, but then also implement low intensity exercises into their program as well. Would that be a good combination to really burn fat in like a quicker amount or a shorter time frame?
Maybe. You could also maybe come up with some low impact stuff and do a type of a high intensity, but it wouldn't be to the level of an athlete doing that. So maybe getting them on a bike and just telling them, you know, for 20 seconds, just pedal faster. You know, or when you're walking, okay, speed up from one telephone pole to another, and then take a recovery till your heart rate's back down.
Because it seems if you were to have a client like in their 50s or 60s that still wants to like lose some weight,
be careful there.
They're not really like in their, like, they don't really have the desire most likely to do high intensity interval training, things like that. So it seems like a combination of a low carb diet and low intensity workout would be better than just high intensity workout.
Yeah, I see what you're saying, and definitely you have to look at that. If you're looking at that population, there are going to be things that they're not going to be able to do well, and you're right, not have the desire. Probably with, if we're talking the older population, I'm going to bump that up a little bit, 60s and 70s. If we're talking there, and maybe they've had a more of a sedentary life, that they, you know, trying to get them to maintain just their independence, so that, you know, as they then move into that next phase of life, they're able to maintain that. Getting them going through the movements alone is good. Just getting them moving is probably good. So yeah, that might be a thing to do for a short period of time. Saying, okay, you know what, we're cutting out, you know, your carbs, and you know, we're going to try to get mostly fat. You know, we'll do this for a week, just kind of get that roaring, maybe 2 weeks. But I don't think you can last much longer on that type of a diet. I don't know. What did they say? How long did they say that you would sustain something to just get it jump started?
Well, the thing I watched, the guy said that it didn't even show that it would help to lose weight
Okay.
if you're not eating carbs. So
Okay.
at least that's what the study showed.
Okay. Yeah, I have to say, in my book, I like doing the, you know, I always say vegetables and fruit are fair game all the time. The carbs maybe to cut out, you know, so increase your vegetables and fruit, but cut out the breads, pastas, and stuff for a little while.
He did say it might help, but he said that no one can sustain it. So
Yeah, it is very hard to sustain. Very, very hard. And you think it wouldn't be. You're like, ooh, I can eat all the bacon I want. But if that, you know, if that's all you're doing, if you're eating, you know, that type of food, I mean, that's hard to keep going. I would say, you know, Sam, I would say probably work on, first and foremost, look at what calories are they drinking, what calories are coming from processed foods, and maybe make a switch in there. That will make a difference, I think. So, but I do hear what you're saying. You can kind of, just because you're getting them moving, you know, just adding in, it's not going to be that high intensity, but adding in a little bit of interval type within that. Okay, but good question. Okay, so major source. So your carbohydrates come into play when you're at a very high intensity anaerobic. Okay, high intensity aerobic, anything prolonged, and intermittent high intensity sports. So when do carbs, yeah. So really low energy intensity, so we're talking very beginner, okay, and we're talking at rest for the fat. So carbohydrates really is the main source throughout a lot of different levels of activity. I wanted to, and also, okay, so this is something else, I'm gonna let you go ahead first.
when you say you burn more calories for high intensity, do you mean as far as it boosts your metabolism more, so you burn more calories over the fat?
Yeah, so you're, yeah, and even within the time frame, so you can't work at a true high intensity level, I would say longer than 30 minutes, and I would even maybe back that up. So when I say 20 to 30 minutes, including warm up and cool down, I'm serious. You know, because if you can last an hour, it's not a true high intensity. It might be more of a moderate, maybe a higher moderate end. And so you know, when you're doing that kind of time to time, there would be more calories burned in that 20 to 30 minutes of high intensity than in 20 to 30 minutes of low intensity. You're going to get there, but not many people can go out and do the 10 miles. You know, so if we're talking in this general thing, the number of calories burned per same time frame is going to be higher here. And so even though the percentage of fat burned is less, you're going to end up burning more total calories of fat because the number of total calories is higher. Did I make that work? Okay. I did want to say, so another reason that making sure you're getting carbohydrates is important is because even at rest, it is your main source of nutrients for the brain, the central nervous system, and your red blood cells. Okay? So, so even though fat is the main energy source, if we're looking at our brain, central nervous system, and red blood cells, those carbohydrates are still important. All right? So that, think about that. But if we're looking at muscle energy, only 15 to 20% at rest is coming from the carbs, and the fat would be at a higher level. All right. So those carbohydrates are important, you know, not just for the energy, but also for what we're doing. Okay, so this is what's going on here. the first major fuel, and I'll show a little diagram that will explain this too. But in the first few minutes of any exercise, they are anaerobic, and this muscle glycogen is the first major source that is used in any exercise. All right, so if you think about this, you know, as you begin an exercise, your heart rate jumps up, and then, you know, even in a race, a long race, at the beginning, you're moving in anaerobic state until kind of you get in a steady state of exercise that is prolongable, that is slow enough that the oxygen can be used to create energy. The reason we have these different systems is the anaerobic system is where you have a quick sugar, oxygen isn't needed, but the stores are depleted quickly, okay? So you can't sustain that level of exercise. But in a prolonged exercise, what's going to happen, you'll settle off, the body catches up a little bit once you get that steady state. Now you're able to use oxygen and move into the aerobic system, okay? Does that make sense to everybody? You good there? Okay, so then, as we talked about earlier, epinephrine comes in. And here it's going to signal the liver and the fat cells to release the glucose and the fat so that can be used. And that the liver is the one that will kind of share that glucose more. The muscle is going to hoard it, and it will be used then, you know, as it's needed. But the liver can re-break it down then into that glucose. Okay. I have a note here. Oh, I already talked about it. Yay. Okay, so so what is happening here? The first 10 minutes, mostly the muscle glycogen. So what is happening is your blood glucose is entering into the muscles to be used, and the liver then has to release some of the breakdown of glycogen into glucose to release back into the blood. Okay? So the blood glucose, when you start an exercise, is going to go into the cells to produce energy so it's coming from the blood. The liver senses this, remember, the stimulation that's going to occur. And then you're going to have glycogen broken back down into glucose so that it can go back into the blood to keep the blood glucose level high. And then in moderate exercise, so if you're looking at that middle range, both the liver and the muscle glycogen will contribute at about equal levels. Okay? And you can see here that within the 20 minutes, your muscles have used about 1/5 of the stored glycogen, and so the blood glucose will need to continue to be uptaken. So as you get in that prolonged state, you know, so we were talking about like at the beginning of a half marathon per se, I think if I remember right, like right at the start, right as people were getting ready to start, they would take their kind of shot of their carbohydrate if they were using the pouch or a drink or whatever at the beginning of the race, knowing they were going to need it down the road. You know, so that was kind of the first time that maybe somebody would take an extra little bit of carbohydrate. And then, you know, maybe a little before halfway, get a little bit more carbs in order to sustain to the end. Okay, so greater than 20 minutes, you have increased fat use, decreased glucose, and then if there is, so in here, this is kind of where it gets a little bit that. So you need glucose really to do the fat burning. As you decrease the glucose use, you increase the fat use, but ketosis is prevented partly because of decreased glucose use, which this confuses me a little bit too. And I was doing a little bit of reading around this to see what my note so So yeah, so as the glucose use goes down, the fat use goes up, and you're still using some of that glucose in order to completely burn that fat. All right, but if you move into ketosis, that is really when you hit the wall, okay? So in this case, bring that whole thing back around. In order, switching to the fat burning with some of that glucose still there prevents you from hitting the wall. All right, did that make sense? I'm trying to keep talking around that one. But if that glucose completely goes away, then you are going to hit the wall. Okay, when those stores are gone. All right. Any questions there? Let me see, I made one other little note here. Oh, so you have kind of in that moderate level, you have both the liver and the muscle glycogen being used. As it goes up, that switches more to the muscle glycogen. Yeah?
So what do you use once the glucose is gone?
You know what, it would be that fat burning. So if your body was already trained to do that, it might work, but here's the problem. They still say that your body, it won't last as long in ketosis. Okay, so ketosis would be that just complete fat burning, but it doesn't work well if there's not some glucose there. Okay, and you will hit the wall. I've seen in races, people just, they're just done. They can't do anything. That is what happens. Their energy sources are gone, they didn't prep right, or they were sick and their body didn't use it efficiently, and they can't go on. They cramp up, yeah, they're a mess. Even disoriented, you'll see that in endurance people. If you ever go to one of the longer races and you'll watch people just, yeah, you guys could probably tell some stories. But and you can tell, like, boom, they just can't go on anymore. So, yeah, does that help? So don't let it happen, right? So that's why it's really important when somebody is training for a longer endurance type of a thing, that they have that preparation, they have in place what they're going to do to make sure the carbs are there. So, and we'll talk about carbohydrate loading on Monday, and that can help sustain that for longer. So, so when you're doing this, from 1 liter of oxygen, and you guys know this, we did this in 153, right? When we figured out how many calories you burn, that from 1 liter of oxygen, you'll burn 5 calories. Okay. So carbohydrate, it's used both anaerobically and aerobically, and this is really interesting too. So the ATP production per unit, when we're looking at oxygen coming in, there is more ATP produced if a carbohydrate is used as opposed to from a fatty acid. Now we think because, you know, a gram of carbs is 4 calories, a gram of fat is 9, right? So you kind of think, oh, you know, you would burn more, but no, the process that fat has to go through uses up some of the energy, and so you only end up with 2.3 ATPs from fatty acid, where you're going to end up with 2.7 ATP from carbohydrate. So it is a much more efficient pathway that has to happen there. And so just to go through, if we're looking at, and it's actually like 5.05 calories from oxygen, fat is 4.6. And, you know, so it's a little bit less there, and you know, just kind of, if we're talking generally speaking, when we talk about burning calories, we just say 5. So just kind of this process, so think through, carbohydrate yields 5 calories. The ATP production that comes from a unit of oxygen is 2.7 ATP. The carbohydrate metabolic pathway is more efficient, and because more oxygen is needed for the fat to be processed. And so in the end, we're looking at that for in aerobic state, The ATP production from carbohydrate is 3 times faster than from fat. Okay, so in our aerobic state, the carbohydrate is 3 times faster ATP production than fat. And once you hit the anaerobic state, that is even more efficient carbohydrate to fat. Okay, so if we want to talk about athletic performance, I really think you'll see that some good carbohydrates is going to help with that. Okay, help to sustain what you're doing, and also to be able to make that intermittent shifting. So if we think about a sport like soccer, my goodness, so you have to have that aerobic base, and then you have this intermittent sprinting in there. So you're talking about all these different things. Now here, this is showing you, by making sure you have the proper carbohydrates in your system, are going to help your sports performance go up. Okay, so that's important there too. All right, yeah, did you?
So if you were to increase your muscle glycogen storage by whatever you eat, does that mean you could perform anaerobically longer with the more glycogen you have? Because it says that like glycogen is the first thing you burn, because the first few minutes of exercise, of all types of exercise, is anaerobic. Does that mean the more glycogen storage you have in your muscles, the longer you can go anaerobic?
Yeah. So think or I would say the faster you're able to perform.
Okay.
So
So like for a 400 runner,
Yeah.
it's important for them to have like a big glycogen storage rather than just normal glucose.
Yeah.
Okay.
Yeah, 400 run, I mean, that's just a whole nother ball game, right? Holy cow. So all out sprint almost for as long as you can handle, you're gonna die down. So basically, you think of the 100 meters, pretty much at the end of that, your first system is done, So then you're kind of moving in, and you're like, you're still not quite using oxygen, so to be able to last for that 400 meters as fast as that is run nowadays is incredible. And really it comes down to, so think if you increase muscle mass, and we'll be getting, let me see if I'm going to get there. Oh, maybe it's later. I went over, it'll come, but all the different advantages to endurance training, it would still be the base for those middle distance, but then to keep training anaerobically and fueling the body properly is going to cause that body, kind of that specific adaptation to impose demands. When your body knows it's going to be called upon to be able to do that. Usain Bolt, I mean, holy cow, right? And his form isn't even the best form out there, but somehow he can make it happen. But it really is, and some bodies will naturally do that anyway, have larger stores than others, which is why, some people are able to move on to that next level of competition. I watched Nathan Martin, I'd be out driving and watch him sprinting in my book, right? For a marathon. I mean, that's just nuts. But definitely, so making sure the stores are there, fueling properly the night before, and just getting the body to its optimal efficient use of those by training is going to help. So, yeah, there are a lot of things in there, but if we're talking nutrition-wise, yeah, making sure they're carbs